we're going to jump in on learning Python into the chapter 2 of the book. So we're going to double click our PDF file that we downloaded. This is going to be, so we want to go ahead and just open it up just a little bit here. We're actually going to get down to chapter 2. Okay, so notice I'm going to go by the table of contents and all this. We're going to skip some of the introductory stuff. You should read it yourself, but so let's go ahead. We're going to start with chapter 2, the interactive shell. Some of this stuff is actually easier to read online. I like the PDF just because you can't copy and paste. It produces a little bit of the desire to copy and paste. So let's start at the top of the chapter 2. So before we start writing computer programs, we should learn some basic programming concepts first. These concepts are values, operators, expressions, and variables. We won't start programming this chapter, but knowing these concepts and the names of these things will make learning to program much easier. This is because programming is built on only a few simple concepts combined together to make advanced programs. Let's start by learning how to use Python's interactive shell. To open IDLE on Windows, click on Start Programs Python 3.1 IDLE. Now, for the purpose of this video, we are not going to use IDLE, obviously, so we're going to be using our portable Python console. So let's go ahead and open that now. So I go to my Python folder, open up Python Portable. Okay, so this is my Python shell, and you'll notice it looks exactly or very similar to what we see on the screen. Okay, so I'm just going to go ahead and kind of collapse my book here so I can see both at the same time. Okay, so as you can see, the Python shell, Okay, as you can see in figure 2.1, the computer should respond with the number 4, sum of 2 plus 2. So it tells us to type 2 plus 2, and you should be doing this as I do it with the video. Okay, so you should be following right along. So you should now opened up the console and entered 2 plus 2. We'll type enter, and it gives us 4. Okay, as you can see, we can use Python shell just like a calculator. This isn't a program by itself because we're just learning the basics right now. The plus sign tells the computer to add the numbers 2 and 2. To subtract the numbers, use the minus sign. To multiply numbers, use an asterisk like so. When used in this way, and we'll see the table right here, so when used in this way, plus, minus, asterisks, and forward slash are called operators because they tell the computer to perform a specific operation on the numbers surrounding them. Integers and floating point numbers. In programming and also in mathematics, whole numbers like 4, 0, and 99 are called integers. Numbers with fractions or decimal points like 3.5, 42.1, and 5.0 are not integers. In Python, the number 5 is an integer, but if we wrote it as 5.0, it would not be an integer. Numbers with decimal points are called floating point numbers. In mathematics, 5.0 is still considered an integer, and the same as the number 5. But in computer programming, the computer considers any number with a decimal point as not an integer. Try typing some of these math problems into the shell. Press Enter key after each one. Okay, so I'm going to start typing here. Plus 2, plus 2, plus 2. Enter. I get 8. Oops, I missed a 2 there. 8 times 6. Enter. 48. 10 minus 5 plus 6. Enter. Is 11. 2 and some spaces plus 2 is 4. Okay, in Figure 2.2-2 is what the interactive shell in IDLE will look like after you type in the instructions above. These math problems are called expressions. Computers can solve millions of these problems in seconds. Expressions are made up of values, the numbers, connected by operators, the math signs. Let's learn exactly what values and operators are. As you can see with the last expression in the above example, you can put any amount of spaces in between the integers and these operators. But be sure to always start at the very beginning of the line with no spaces in front. Numbers are a type of value. Integers are a type of number. But even though integers are numbers, not all numbers are integers. For example, fractions and numbers with decimal points like 2.5 are numbers that are not integers. This is like how a cat is a type of pet, but not all pets are cats. Someone could have a pet dog or pet lizard. An expression is made up of values, such as integers like 8 and 6, connected by an operator, such as the multiplication sign. A single value by itself is also considered an expression. In the next chapter, we will learn about working with text and expressions. Python isn't limited to just numbers. It's more than just a fancy calculator. Evaluating expressions. When a computer solves the expression 10 plus 5 and gets the value 15, we say it has evaluated the expression. Evaluating an expression reduces the expression to a single value, just like solving a math problem reduces the problem to a single number, the answer. The expression 10 plus 5 and 10 plus 3 plus 2 have the same value because they both evaluate to 15. Even single values are considered expressions. The expression 15 evaluates to the value 15. However, if you type 5 plus into the interactive shell, you get an error message. Now notice that I hit a box here. Okay, so every time I see a box, I'm going to type in exactly what it says. So I do 5 plus, enter. Oh, and I get syntax error, invalid syntax. This error happened because 5 plus is not an expression. Expressions have values connected by operators, but the plus operator always expects to connect two things in Python. We have only given it one. This is why the error appeared. A syntax error means that the computer does not understand the instruction you gave it because you typed it incorrectly. Python will always display an error message if you enter an instruction that it cannot understand. This may not seem important, but a lot of computer programming is not just telling the computer what to do, but also knowing exactly how to tell the computer to do it. Expressions inside other expressions. Expressions can also contain other expressions. For example, in the expression 2 plus 5 plus 8, the 2 plus 5 part is its own expression. Python evaluates 2 plus 5 to 7, so the original expression becomes 7 plus 8. Python then evaluates this expression to 15. Think of an expression as being a stack of pancakes. When you put two stacks of pancakes together, you still have a stack of pancakes. And a large stack of pancakes can be made up of smaller stacks of pancakes that were put together. Expressions can be combined together to form larger expressions in the same way. But no matter how big an expression is, it also evaluates to a single answer, just like 2 plus 5 plus 8 evaluates to 15. Storing expressions in variables. When we program, we will often want to save the values that our expressions evaluate to so we can use them later in the program. We can store values in variables. Think of a variable like a box that can hold values. You can store values inside the variables with the plus sign, called the assignment operator. For example, to store the value 15 in a variable named spam, enter spam equals 15 into the shell. So I'm entering spam equals 15 into the shell, right? Enter. Okay. You can think of the variable like a box with the value 15 in it. So you can think of the box like a value. You can think of spam like a box with a value of 15 in it. I lost my place. Let me just find it again. The variable named spam is the label on the box, so we can tell one variable from another, and the value stored in it is like a small note inside the box. When you press enter, you won't see anything in response other than a blank line, unless you see an error message. You can assume that the instruction has been executed successfully. The next prompt will appear so you can type in the next instruction. These instructions, called an assignment statement, creates the variable spam and stores the 15 in it. Unlike expressions, statements are instructions that do not evaluate to any value, which is why there is no value displayed on the next line in the shell. It might be confusing to know which instructions are expressions and which are statements. Just remember that if the instruction evaluates to a single value, it is an expression. If the instruction does not, then it's a statement. An assignment statement is written as a variable, followed by the equal sign, followed by an expression. The value that the expression evaluates to is stored inside the variable. The value 15 by itself is an expression. Expressions made up of a single value by itself are easy to evaluate. These expressions just evaluate to the value itself. For example, the expression 15 evaluates to 15. Remember, variables store values, not expressions. For example, if we had this statement, spam equals 10 plus 5, then the expression 10 plus 5 would first be evaluated to 15, then the value 15 would be stored in the variable spam. The first time you store a value inside a variable by using an assignment statement, Python will create that variable. Each time after that, an assignment statement will only replace the value stored in the variable. Now let's see if we can create our variable properly. If we type spam into the shell by itself, we should see what value is stored inside the variable spam. Okay, so I type it in and enter. Oh, there it is, 15. Now spam evaluates the value inside the variable, 15. And here's an interesting twist. If we now enter spam plus 5 into the shell, we get an integer 20 like so. That may seem odd, but it makes sense when we remember that we set the value of spam to be 15. Because we set the value of the variable spam to 15, writing spam plus 5 is like writing the expression 15 plus 5. If you try to use a variable before it has been created, Python will give you an error because no such variable would exist yet. This also happens if you mistype the name of the variable. We can change the value stored in the variable by entering another assignment statement. For example, try the following. The first time we entered spam plus 5, the expression value is to 20 because we stored the value 15 inside the variable spam. But now when we enter spam equals 3, the value 15 is replaced or overwritten with the value 3. Now when we enter spam plus 5, the expression evaluates to 8 because the value of spam is now 3. To find out what the current value is inside a variable, just enter the variable name into the shell. Now here's something interesting. Because a variable is only a name for a value, we can write expressions with variables like this. When the variable spam has an integer value of 15 stored in it, spam plus spam is the same as entering 15 plus 15, which evaluates to 30. Spam minus spam is the same as entering 15 minus 15, which evaluates to 0. The expressions above use this variable spam twice. You can use variables as many times as you want in expressions. Remember that Python will evaluate a variable name to the value that is stored inside that variable each time the variable is used. We can use the value in the spam variable to assign spam a new value. Notice that was a little bit different than what was printed in the book. So I had to assign spam a new value and then tell it to evaluate spam. The assignment statement spam equals spam plus 5 is like saying the new value of the spam variable will be the current value of spam plus 5. Remember that the variable on the left side of the sign will be left sign of the assignment operator, or the plus sign, will be assigned the value that is the expression on the right side of the will be assigned the value that the expression on the right side evaluates to. We can also keep increasing the value in spam by 5 several times. Overwriting variables. Changing the value stored inside a variable is easy. Just perform another assignment statement with the same variable. Look what happens when you enter the following code into the interactive shell. Initially, the spam variable is 42, had the integer 42 placed inside it. This is why the first print spam prints out 42. But when we execute spam equals hello, the 42 value is tossed out of the variable and forgotten, as the new hello string value is placed inside the spam variable. Replacing the value in a variable with a new value is called overwriting the value. It is important to know that the old value is permanently forgotten. If you want to remember this value so that you can use it later in your program, store it in a different variable before overwriting the value. Notice I got a syntax error because I forgot my parentheses for the print command. Okay, in the above example, before overwriting the value in spam, we stored the value in a variable named old spam, using more than one variable. When we program, we won't always want to be limited to only one variable. Often we need to use multiple variables. For example, let's assign different values to two variables named eggs and fizz, like so. Now the fizz variable has 10 inside it and eggs has 15 inside it. Without changing the value in our spam variable, let's try assigning a new value to the spam variable. Enter spam equals fizz plus eggs into the shell, then enter spam into the shell to see the new value of spam. Can you guess what that will be? The value in spam is now 25 because we add fizz and eggs. Because when we add fizz and eggs, we are adding the values stored inside fizz and eggs. In this chapter, you learn the basics about writing Python instructions. Python needs you to tell it exactly what to do in a strict way because computers don't have common sense and only understand very simple instructions. You have learned that Python can evaluate expressions, that is, reduce the expression to a single value. and that expressions are values such as 2 or 5, combined with operators such as plus or minus. You have also learned that you can store values inside of variables in order to use them later on. In the next chapter, we will go over some more basic concepts, and then you will be ready to program.